Okay. Once again, we're recording. And I think I have a linked list directory. And I have this right here, which I've called linkedlist.c. Is that big enough for everyone to see? Should I make it a little bigger? Okay. And so, here is the data structure that we saw in the textbook and in the slides that I just took out of the textbook. If Natan's question was, what if we wanted to store anything, then we could do that, and then we could just decide what it is. We'd probably need something to go with it, like some sort of something. Maybe you have an integer, and if it's 0, it's a pointer to an image, and if it's a 1, it's a pointer to something else. But something about how to interpret it. But we're just going to do character strings. And so then here's something that's very similar to the example in the book, where we've got a head node, and then we're going to insert all the universities in Oregon, and then we'll have something that prints, and then we'll remove something from the middle, and then we'll print it again. So we need to implement 3 methods, which are insert, and remove. By the way, I should do some VI stuff here too, okay? So I did my insert, and then here I want these 5 lines. I'm going to say 5YY. I go down there and say P, and now I've got those lines. Kevin?
Why are we using typedef?
Yeah, that's a great question. The question is, why are we not using typedef? And the reason why is because we have a type node, and in it, it has a pointer type, which is also a node. And so if we did this, and we put node here, the compiler runs risk of getting confused, because when it sees node, it says, I don't know what this node type is, because it's not smart enough to look at the very next line to see that the type is node. Okay, so I believe, well, I'll tell you, so let's queue that up, and I will try to fix it. I think there's a way to fix it. But let me get a little further so we can actually get to a spot where we can compile, and then I can try to fix it and see if it works. So I'm going to change this to be remove. Oops, and I've done this wrong because okay, so here's another good one, okay? So here's my cursor. I press $sign to get to the end. Okay, I'm going to press insert, comma, and I need to take a pointer to a node. I press escape, and then if I go down here in the same position and I press dot, it repeats what I just did. Okay, so if you're doing the same thing over and over again, set it up just right, and then just put your cursor in the right spot and just dot, 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 dot. Cody?
I have a question about
Yeah.
when you search something, how do you go to the next thing that might be spelled the exact same?
Good. So if I'm looking for LL insert, now let's look for LL print. So I did a slash, which is a forward search, right? And I type in what I want, and I press enter. And then if I want to search again, I can just press slash and enter, and that's assumed to search for the same thing you just looked for. So I don't have to type in LL print again. And if I do question mark, it'll search backwards. Kel?
Wait, so can you explain the dot more?
Yeah, so if I enter edit mode, whether it's through an I or an A or a shift I or a shift A, then I do whatever I want for editing, and I press escape. And from the beginning of entering edit mode to the end is one command. And dot just says, do that again.
So it doesn't matter like what it looks like. If you press dot, it'll just do exactly what you just did.
What you just did again, okay. Yeah. So just to even go further with it, like if I wanted to change out the first 3 words here, I could say, so CW is to change a word. So if I press CW, then it will remove university, and I'm in edit mode, and I can say, like college, right? And then I can just search for university. okay? And then if if I want to switch three things, then I could do like 3 change word, and then type University of Oregon, and then it's going to get ucky because if I change these 3 words, then I'll just get University of Oregon twice, right? And by the way, everyone knows U is undo, right? Okay. So and then I'm going to say $%s, and so this calls sed, which we talked about sed in one of the lectures. So sed will replace one pattern with another. This is calling sed, and I'm going to replace college with university, and now I'm back where I started. Yeah. So I will say, I think this stuff is in Vim Tutor, and of course, we put you in a situation where you were all drinking from the fire hose at the beginning of the term, and I think many of you did Vim Tutor, and if you did it again, you may actually get more out of it, like from now that you've lived with the VI for a few weeks. Quentin?
So you have a typo, LL remote.
Thank you. Okay, so now we've got our functions. Let's see if we can compile, right? So we cannot. So it says a parameter name is omitted. I don't see why that's a problem. Repeatedly, 11, 16, and 21. I'm troubled that I wouldn't think that would tell me it's an error. Yeah, I would think that it's fine to say this is the argument, I don't want to use it. And then 2 of these say, this one, okay, so now we can compile. Okay, by the way, I encourage you all to compile as frequently as you can. I could have done it more frequently because I could have added one function, compiled the one function and the next. So now to Kevin's question. So if I do this, I don't think it's going to like it because at this moment it'll say I don't know what a node is. And I don't want to see all the other errors, so I'm going to comment out everything else. Okay, so now it's only going to compile these first 2 lines. And if we do this, oh, it worked. So this compiler's smarter than some. I thought it would say, I don't know how to deal with a node. The way that you can defeat that is you can do a so-called forward declaration and tell it there's going to be a declaration coming of a struct called node. And that's a way to get around that. Natan?
Could you explain the syntax of struct, LL, node, LL insert? I'm just confused as to what's happening there.
LL, yeah, so good. So it looks like we can take out all these structs. Here, let's just compile. See, I do this sort of stuff all the time. I'm going to make a change. I want to see how it works. I'll just make a backup all the time, right? I have so many backups of things. So I'm going to go here, and I'm going to take out struct with a global replace. I'm replacing struct with nothing, and that's going to take out all these structs everywhere. And it took out one too many because I wanted to have a struct up here. So let's just do that and see if that, whoops. Well, that was really bad, huh? I just copied over my backup. Whoops. Ah. Okay, don't worry.
It's my favorite error.
LL node with struct LL node. So now we got it back, okay? So the first thing is a return type. I think so. I actually am not eager to be pursuing exactly when I need the keyword struct. I thought maybe I could answer Kevin's question, and I think it's going to pull on a whole bunch of yarn I don't want to be pulling on. So I'm not going to pursue whether or not we need the struct keyword. I'm going to assume we do. Natan, to your question, this is the return value, and for my personal programming preferences, I like to put the return value on its own line. And then this is the function name, and then these are two arguments to the function. Kevin?
Wait, you know how you just overridden your backup?
Yeah.
earlier? Is there any way you can get that back?
No. You're lost. So let me see. Yeah, so the question was, if you overwrite your backup, what can you do? Let me say, there might be stuff with Max Time Machine. I've never really investigated. I know that on X, they take regular backups, and so X is the department Unix machine. You can go to some of the, you can actually find backups and get copies of things. But often if you make something and you overwrite it seconds later, you're SOL. So. Okay, so let's go back here. So we're back to compiling. So, can we implement an insert? Yes? Here we go. So we're going to need a node. So there's a new node. And we want to set the node's value to name. Now let me say, this is wonky right here, this line of code, because you know, if someone went and we're just copying the pointer, right? So to be really clear, this equality is setting this pointer to be equal to that pointer. So we're now sharing a memory location. If someone goes and modifies name that was passed in, this one would get modified. So it might actually be better to make a copy, right? And that's what they do in the textbook. So, but I'm not going to, because I mean it's easy. You just do this. There's actually a command called string dupe, which would make a copy of the string. So that allocates new memory via malloc and copies the string. But I'm just going to keep it simple. Okay, and now it's actually really easy, right? What should we do next? So let's go back to our choo-choo train. What are our choices? So we know, one second, Cody. We know that at the beginning, the head is pointing at nothing. But at some point, we're going to have something where there's like 4 of these. Where do we want to insert it? There's only a couple options. We can insert it at the beginning, we can insert it at the end, or we can insert it in the middle. Who wants to insert it at the beginning? Ann does, good. Who wants to insert it in the middle? Who wants to insert it at the end? Ann's right. You want to insert at the beginning, right? Because if you want to insert at the end, you got to walk all the way to the end. Why pay that cost? If you insert at the beginning, it's easy, right? So let's insert it at the beginning. How do we insert at the beginning? Actually, not too bad. New node next equals head. Return new node. So the return value of LL insert is the head. Not so bad, right? Remove. This one is harder. Let's do a print. And in fact, I'm going to change this one to return the head. Because one of the things I want to do is demonstrate that we should test regularly. I'm not really testing very well, but print functions are super useful for testing. So we'll say struct LL node equals kernode equals head, while kernode does not equal null. What do you think? I'm gonna make it a little fancier. You ready? Now it's going to say the list is, and we're going to indent it. The tab will indent, and we'll put a number with it. Okay? Let's compile and see if it works. It doesn't. So the first thing is it says invalid application of size of to an incomplete type. I think that's getting messed up by the type def. So let's get that out of there. Still didn't like it, huh? Malloc size of struct LL node. Yeah, because all these say LL node, but this says node. That's a problem. By the way, you guys see, it's so important to me to have like the white space, right? You see, I inserted LL underscore, and then it made it like all not line up, and I said, oh no, I won't deal with that, right? And I put in the spaces. You know, people notice this stuff. You have your code examples. It's easier to read. When people are hiring you, they'll notice stuff like that. Hey, good. So we only had one problem. The one problem was we called our struct node, and everywhere else it was called LL node. So if we run it, looks good. All 7, the list is this. We removed Oregon Institute of Technology. Well, we didn't, right? But we were able to run our program now. So now we're down to one thing left, which is the remove. So this one gets tricky, right? So first off, if someone says to remove and it's the engine of the train, that's a little different than the case where you're removing something from the middle, right? Do you guys see that's a different case? So I'm just going to handle that case specially. If string compare head, well, if head equals null, return null. If string compare head value and name equals 0, return head next. Right? That's just saying go to the one after the engine. That's the new head of the linked list. Okay? Now, by the way, why did I not do this? Why did I not do that? Let me think about it real quick, Natan. Okay, Natan, tell him. Why did I not do that? That's comparing 2 pointers. It's not comparing 2 strings. Right? So it could be the strings are identical, but there's 2 different memory locations that have identical contents. Okay, so now we got to do the tricky thing. Struct LL node cur node equals head. How about this? So what do we want to do? I have to think about this. If this is a node we want to remove, then we need to tell the previous one to point at the next one. That does it, right? So I'm going to have a previous and a current pointer. So this says, so I've got a previous and a current. So here's previous, here's current, right? And I'm going to iterate through here. And I'm going to have, let's see if I can do this in PowerPoint. So what I want to do is I want to say if the current one is the one to be removed, I want to go to the previous and have its link point at the next one. And then if it's not, then what I'm going to do is I'm going to take my pointers, darn it. I'm going to take my pointers and I'm just going to scoot them down one. And if the current's not the name then, I'm going to take my pointers and just scoot them down one again. Okay, and that's what this code right here is doing. Natan?
Shouldn't it be per node equals per node next?
Because I had set previous node to cur node, then it would work, right? But I'm happy to, yeah, I mean, both would work, right? Yeah. And so then how do we remove? We say prev node next equals cur node next. And we break. And break was take us all the way out of the while loop to the end. And?
Do you need a special case if the thing you're removing is the last item?
You don't actually. It's a great question. So if we get right here and current is the one to remove, well, current next is null. And when we set previous next to current next, we're just setting it to that null pointer. So you're exactly right. Is there a special case at the end? And it turns out that since there's a null pointer right here at the end of the train, we're just copying that null pointer over. Okay, I'm a little nervous. Looks good. Okay, so because remember, our code was to remove Oregon Institute of Technology. That's the one we removed. And then we did it. The first time we had OIT, and the second time we didn't, and we had Portland State. Okay? Any questions? I'm going to stop the video. Like and subscribe. Any questions about singly linked lists before I stop the video? Okay?